My name is Rich Petersen. I'm one of the co-founders, together with Serge, of JetStream Software. We officially launched the company in the spring of this year, but as Stephen said, our team goes back quite a ways. We actually started in 2009 working together. Our original startup was acquired by SanDisk in 2012. SanDisk then was acquired by Western Digital in 2016, and we seized the opportunity to get the band back together, take our technology, and restart as a new company with Western Digital's full support. So worked out very well. Today what we'll do is we'll introduce you to our technologies and the products that we are shipping, as well as the product that we just announced, and when it will be out later this year. So our focus is on the cloud and cloud performance with our JetStream Accelerate product, cloud migration with our JetStream Migrate product, both of which are now generally available. And then we'll spend the latter half of the presentation talking about data protection and what we're doing there. Throughout the presentation, we're going to refer to three basic areas of competence. Our experience using I/O filters, which I believe you're all familiar with. If not, we can discuss that a little bit. Our experience managing I/O latency with non-volatile memory, and then our ability to manage data across physical locations. These are areas where we've been doing development consistently since we came together as an organization. By the way, I have 5 slides. Okay, so don't panic. We'll talk really briefly about I/O filters. We actually partnered with VMware as the design partner for the caching filter in the I/O filter API framework. So basically, Serge led the team that collaborated with the VMware engineers as they were developing the vSphere APIs for I/O filtering. Our original reason for collaborating was to enable our caching software to run in the vSphere hypervisor without it being in the kernel in any way. So the APIs actually allow data services to intercept the I/O between the virtual machine and the virtual disk in user space. So if we have an incident with a single VM, we're not hurting the kernel. The vSphere APIs have been out for a number of years, but to date, JetStream Software is actually the only company with 2 shipping products using the I/O filters. We use the caching filter for JetStream Accelerate. We use the replication filter for JetStream Migrate. Is everybody familiar with I/O filters, or should we spend a little bit of time? I'm getting nods, like, yeah, keep it going. Okay. All right, good. So the best thing about it for our customers' perspective, of course, is that when you use I/O filters APIs exclusively for integration in the hypervisor, you can be fully supported by VMware, which is a very important point for us. All right, I'll talk a little bit about how we use I/O filters in JetStream Accelerate. This is the product that we actually introduced in Tech Field Day a number of years ago when we were at SanDisk, so I'll go relatively quickly since it's a very mature technology foundation. Basically, the I/O filter sees all of the I/O activity. It identifies the data that's being read most frequently, makes it available from non-volatile memory that's installed in the host server. So basically, it's a way to take a lot of the read traffic off the underlying storage, improve application performance, and also improve virtual machine density. Recently, we did actually do an update to JetStream Accelerate at the request of one of our customers to support Oracle RAC. It introduces an interesting problem because caching is managing data on the north-south data path between the cache and the host and the underlying storage. But we also now had to reconcile the data at the application cluster level between the 2 caches and the separate hosts. So Serge led the team that did this. This was at the request of one of our customers, BT actually. And so we collaborated with VMware and with Oracle to develop this for BT, and they're rolling that out now. We actually introduced and presented that solution earlier today at VMworld. The second product that we are using I/O filters in is JetStream Migrate. And JetStream Migrate, I mean, there are a lot of solutions for virtual machine migration. What we set out to do was to build the simplest yet most powerful solution for migration at the request of cloud service providers that said, I'm tired of telling my enterprise customers that they have to deploy a DR framework just to migrate their VMs to my hosting capability. And so what we did was we take the I/O filter And we take a copy of the virtual disk, we replicate the copy of the virtual disk to the destination. At the same time, applications and VMs are continuing to run on premises, but the I/O filter is intercepting all of that new data, that's being written. So we have parallel replication processes, the copy of the virtual disk and the replication of the newly written data to the destination. In doing that, we're able to allow the applications and the virtual machines to continue running while their data is being physically copied over to the destination. And that copying and transport can take place over the network, or it can take place by a physical device.
So this is happening live. Once the JetStream migrate gets initiated, it also initiates the process of replicating that data to 2 locations, whatever change data is taking place.
That's right, that's right.
And is there anything kind of buffering I/O on the source side in case the network link is just not capable of handling whatever the stream is, if there's some kind of burst?
Hey, great question. Do you want to talk?
We don't. For DRE, yes, we do, but for replication, we don't.
Well,
and maybe you can see that we have still fault tolerant. How we achieve this? Because your question it's a right question. Actually, we have 2 copies of metadata in a master host where VM is actively running, and in another host in a daemon. Because daemon it's a another VIO object running. So we have 2 copies of metadata. If anything happened with this host, we always have metadata here. So we do not need to provide for migration product data consistency during this migration. It's only in the last moment we have consistency. Because of that, for that product, we do not need log of data, but we do have redundancy for metadata.
And my question is more about the continuous replication after that initial, as data is changing, if there's some kind of bursty I/O happening on a VM that is being protected to another site,
so
and if it exceeds what the network link between the sites is capable of, are you going to be able to buffer it so it can kind of catch up later if it's not capable of doing it in real time?
Right. Well, the idea for migration is to not require any specific hardware, either in the on-premises environment or in the cloud destination. Now, in the case that you're talking about, we do have what's called a back pressure control. Okay, so we can either, in the event that the write activity in the on-premises environment is overwhelming the network connection to the destination, we can throttle the I/O in the on-premises environment. And we can also throttle the network in the event that a very powerful network is causing the application on-premises to slow down. So we have dual back pressure control in that situation.
But even without back pressure, if, for example, network is down for 2 hours, we do not start replication over. We accelerate metadata, and when connection is back, we just apply this delta, and we're back to the business. This is very important here. Network delay or interruption, host failure, or it's a lot of new data. In this case, yes, we can apply runtime back pressure. Just if amount of generating data is this and network bandwidth is this, you can, or if impact on performance, application performance is too high, we say, okay, slow down replication. Because for replication, we're reading data from here because it's original data from.
So there's a cache catch up at the very end. Is there cache coherency?
There is no cache coherency, it's just data coherency. Data on a destination, when we provide final migration, this is consistent and exactly equal to this.
Can back pressure be controlled on the destination side? Say you're a service provider with a lot of customers and you don't want one customer to steal the share from others if they have a particularly high amount of data to send?
Yeah, we do not have back pressure in this site.
Right.
But we do have, as I said, back pressure here. And we do not provide SLA or whatever in a destination because it's not our, it's not our responsibility, I would say. Typically, if a cloud provider, let's say, they they will manage this migration. They will do it with our back pressure over here.
So they would have control inside the tenant environment to
Yeah,
handle that.
yeah, we have.
That can be managed by a QoS on the network side.
Right.
Assuming my customers know how to do that, though.
So,
So is this intended to be for a one-time migration of your virtual machines, or is it to keep them synchronized?
you're exactly right. It's a one-time replication. So the idea, what happened was a number of our cloud service provider partners said, can you use I/O filters to come up with a simpler way for a one-time migration when somebody wants to move from their data center to my hosting environment? Okay? They don't want DR. They just want to move their VMs and their data. And that was the problem that they approached us with. The idea that we could use I/O filters meant that we're only deploying a filter. It's being controlled and managed by vSphere. When they're done with the migration, vSphere can automatically uninstall the filters from every host in the cluster. So we basically go in, facilitate the migration, and then disappear. We leave the scene entirely. And then it's up to the IT group to determine what they want to do with their on-premises environment. But it's got the lightest footprint of any solution that we know of for the migration of data because it just uses that filter and a plugin in vCenter for managing the process.
So this is implying on-prem going to cloud.
Yes.
Have you seen it the other way?
What we've seen is more cloud to cloud in the sense that our larger cloud managed service providers have multiple data centers, and they quite often want to move virtual machines from one data center to another, or from one cluster within a data center to another cluster, and they'll use the tool for that. Yeah. Would you like to see it working?
Rich, maybe
sorry, go ahead.
you didn't.
Okay, well, I think I did mention it, but what's very important is there are a couple of things about the product that we believe are quite unique. The first is the capability to predict and orchestrate the migration process. So prior to the migration, the administrator runs the product in observation mode. We observe all the I/O that's taking place. We probe the replication network. We use that information to say, given the VMs that you've got and the size of their virtual disks, a replication process over your network will take this much time. And you can do that individually, like this VM, that VM, or you can do it in a group of interdependent VMs. So you get an estimation in terms of, well, what's my window going to look like? When can I tell people that they'll be fully migrated? The second, Serge mentioned fault tolerance, but very, very importantly is the ability to support that migration of the virtual disks on a physical device. So you can copy the virtual disks onto a physical device, put the device on a truck, have it go to the destination. The only thing that goes over the network is the newly written data.
And we continue, VM continue running. There is no interruption.
Right.